Now we're going to be going through giant molecular structures. In giant molecular structures, we actually have to study three of them. We always make a mind map before we go into the topic itself. So what are those three that we have to cover? We are going to be doing diamond, we are going to be doing graphite, and we are going to be doing silica. All right, diamond and graphite are actually allotropes. They are allotropes. We'll get to know what they are. All right. So this is what we have to do. These are giant covalent structures. They have different characteristics. Basically, these giant covalent structures have a very different physical and chemical properties as compared to simple covalent compounds. All right, these simple covalent compounds are actually a typical covalent compounds, which means that they have the most characteristics and properties that a covalent compound should have. They are kind of leftists, they are kind of deviants. All right, they have different.
जी
Elaine, बात समझ में आ रही है? Is it clear, everyone? Alishka?
नो सर
Hmm?
जी समझ आ रही है
All right. So the giant molecular structures. You see, the word molecular here actually represents what? Covalent bonding. Do you understand? So I don't need to write every time giant. Yes.
मुझे समझ नहीं आ रही
All right. थोड़ा सा जोर से बोलिएगा. I was not able to hear you.
सर मुझे समझ नहीं आ रही
All right. We have been discussing up till now. We have been discussing simple molecular structures, right?
यस
We have been discussing simple molecular structures. We said that simple molecular, whenever a word molecular comes, it means it refers to the covalent compounds. So simple covalent compounds and simple covalent molecules were being discussed. Now we are going to be discussing a different type of covalent compounds, right? I told you in the beginning that the covalent compounds can be divided into two. Compounds is something that is chemically bonded together, right? We were going to be discussing two. There are simple molecules. The word molecule should be understood that it is talking about the covalent compound. And then we have giant molecular structures. All right, you get it? Simple covalent molecules and giant covalent molecules. We have already studied simple covalent molecules. We are done with them, right? We are already done with them. We discussed their characteristics, we discussed their properties, we discussed how dot and crosses are formed, and we were able to understand how the intermolecular forces also exist between them. Now we are going to be discussing about the giant covalent molecular structures, giant covalent molecules, or giant molecular structures. Is this clear up till now? So the giant molecular structures in these, what we have to discuss in this giant molecular structure is diamond, graphite, and silica. Simple. Diamond, graphite, and silica. These are the three things, the three type of giant molecular structures that we'll be discussing. Among these two, the first two are actually allotropes. You'll get to know what are allotropes. Don't worry about it. And the third one that we have to discuss in this is silica. All right, this is silica, and basically this is carbon, made of carbon, and this is SiO2, silica. Now We say the giant covalent structures have a very different physical and chemical properties as compared to the simple covalent compounds. बस इतनी सी बात हुई है. This is what we have discussed up till now. You
Okay,
get it?
sir.
Simple covalent structures, basically, simple covalent structures are typical covalent compounds. All the characteristics that we have studied up till now for the covalent compound is that they have low melting and boiling points. Generally, they are gases. They do not conduct electricity, right? They are very light, all right? This is what they have: intermolecular forces. These are the things that we have studied about typical covalent compounds, but we are going to see that these giant molecular structures are going to be deviating from these typical characteristics of a covalent compound. Do you understand this point now, everyone? All right, let's
Yes.
get let's get into each of them. Let's start with, first start with diamond. Diamond is a what? Is a giant covalent structure. All right, is a giant covalent structure. A giant covalent structure. One thing that we need to understand, that it is an allotrope. It is an allotrope of carbon. Right. What does allotrope means? Allotropes. Allotropes क्या होते हैं? What are allotropes? Allotropes are different forms of same element. Are different form of same element. You understand this, everyone? We are going to see that there is another
Sir,
structure which is called,
allotropes are two or more different physical forms in which element exists.
no, let's keep it simple. Allotropes are basically two different forms of same element. Two different forms of same element with different characteristics as well.
Okay.
Okay, so graphite, we will see that graphite is one of the forms of in which the carbon exists naturally. We'll see that diamonds are also made of pure carbon. No
Sir,
other element but carbon. Yes.
charcoal.
Sorry.
Sir, charcoal भी allotrope में सकता है.
I'm not able to understand. आवाज नहीं आ रही है सही से, बोले जोर से थोड़ा.
Charcoal.
Charcoal. Yes.
Yes.
What about
सर वो
charcoal?
भी तो सर वो भी तो allotropes में काउंट होगा.
देखो, charcoal, yes, you can say that. ठीक है, charcoal भी होगा, but we are only going to be studying here these two. Okay, you get it?
Okay.
You get it? Basically, charcoal is burned carbon residue होता है वो. Okay, it is a carbon residue. Do you get it? And it
Yes.
also, all the constituents are removed. Okay, but charcoal generally can have other carbon materials as well. It's not purely carbon, it could have other things as well. All right, it could have water in it. Charcoal is actually any organic material that is burned. You get it? If you strongly heat the wood, basically charcoal is what? We're going off track from the topic, but it's okay, you can discuss this. Charcoal hota kya hai basically? Charcoal is actually burned
Burned wood.
wood, right? So wood does not only has carbon in it, but it also have hydrogen in it, also has oxygen in it, also has water in it, also has proteins in it, right? So all of these things when
Okay.
burned, and they produce a charcoal which is a carbon residue. All of these things are burned and gone, and what is left is carbon. But generally, this is not naturally found. This is not something that we really consider as an allotrope of carbon. Okay,
क्या करना होगा
you
नहीं
understand this,
होगा मैं ये
everyone? There's a lot of noise.
वर्ड्स राइट करो
There's a
ब्लू
lot of
कलर चूज
noise from the back. Is this clear, everyone? So generally we'll
Yes.
keep it to graphite and diamond because they are the purest form of the carbon that we can find in nanotopes. Purest, no other element since the beginning till the end, no other element but carbon. No other element but carbon. Do you get it? So allotrope is an allotrope of carbon. The other allotrope of carbon is graphite, and the one we are discussing is diamond. So, so allotropes are substances that have a different are in a different physical, they are in different form, okay, different form of the same element. There, how are they different physically and also chemically? Okay, chemically they are different as well. One of them can be inert, another one can be reactive. All right, so let's talk about physical properties of a diamond, right? Physical properties of diamond. This is going to give us an idea how allotropes are differing from each other and how these giant molecular structures actually completely are different from the simple covalent structures that we have studied. Is this clear? So physical properties में क्या है? Very hard material, solid, very high melting point. You know, do you know how much is it? It's around 4800 degrees Celsius. Very high. Sorry, I apologize. Around 3500 degrees Celsius. Okay. And the boiling point is around 4800 degrees Celsius. It physical properties does not conduct electricity, right? Insoluble in water. You get it? Very hard substance, cannot be scratched easily. You cannot scratch it. Actually, it makes the drill bits of many drilling machines. The bits of many drilling machines. All right. Are you getting this point, everyone? Okay. Another thing that another important thing appears to be crystal, right? Diamond appears to be as in a crystal form, right? Now, why is diamond like this? It has a high melting point. It is solid, very hard, appears to be as a crystal. All of these are not the characteristics of a covalent compound in general, right? These are not the characteristics of a covalent compound. You're not going to find any covalent compound with such characteristics, basically. The simple ones. है ना? So why is it like this? The reason is the bonding that takes place between them. What is the reason? An important point. Reason for such bonding. The reason for the why is it why the what are the reason? What is the type of bonding that contributes to such a physical characteristics and properties. Hmm?
सर
Basic,
फिर से पूछो.
I'm saying the reason
Okay.
behind, we are going to be write this, the reason behind it becoming a giant covalent structure rather than a simple covalent compound, because it has covalent bonding, then why does it has different properties, right? Different from the normal covalent compounds, right? It's different from normal covalent compounds, and the reason is because carbon actually has four, it has four electrons in its outermost shell, and all four of them are what? Lone electrons, right? We know lone electrons are the ones that take part in bonding, right? Lone electrons take part in bonding. What happens is that each of this makes a bond with another carbon. Each carbon is bonded to four other carbons. Each carbon is bonded to four other carbons. Do you understand this? Is this making sense?
Yes.
Each carbon, Hadia, Alishba, everyone, each carbon is further bonded with four other carbons. This cumulatively makes a very large amount of covalent bonds in a network. So many covalent compounds all together in a network, they make up a tremendous amount of bond energy. Okay, you understand this point? So what is the point that we have to keep in mind? Each carbon in diamond is bonded to four other carbons. This obviously this is a covalent bond, right? This creates a network of many covalent bonds all together, right? If you look at carbon dioxide has what? Maximum four covalent bonds together, and it completes a molecule, right? But if you look at carbon, it keeps on going and expanding and expanding and expanding, right? Imagine this many. If one you found a diamond and it had trillions and trillions and millions of carbons bonded to trillions and trillions and millions of other carbons. Do you understand? So collectively, this forms a very large. It requires a very large amount of energy to overcome all of these covalent bonds altogether. You get it? This creates a network of many covalent bonds altogether that requires a very large amount of energy to requires a very large amount of energy to break all of these bonds, the covalent bonds. That is why it has a very high melting point. Do you get it?
Yes.
Is this making sense to everyone? keeps on making crystals like these, you know. Do you understand now, everyone?
Yes.
So this is how it generally appears, right? Keeps on making crystals like these, and it makes a large amount of tremendous amount of covalent bonds all together. They form a very strong network of covalent bonds, strong network of covalent bonds. You get it? Compare it to many other, just have few covalent bonds and the molecule finishes only within 20, 30, 40 covalent bonds. Imagine over here trillions and trillions of carbons and trillions of covalent bonds all together, interlinked, makes a very large amount of energy, and it becomes very strong because of all of that, right? So that this explains why it is so hard. This explains why it has a very high melting point. This explains why it is a solid. All right. Everybody has written this. The next point that we have to discuss about is
Yeah.
electric
G.
conductivity. G, Lean, Alishba, everybody has understood this point. Why is diamond so strong? Because this is the line that you have to
Yes.
stick to. This is what you have to keep in mind in your exam. Each carbon in diamond is covalently bonded to 4 other carbons. This creates a large network of covalent bonds altogether, making it very hard and raises its melting point to at a very high level. Electric conductivity. We have already discussed that electric conductivity actually depends upon moving particles, right? Electric conductivity. If you need to conduct electricity, you need to have moving particles, and those moving particles can be either electrons or ions. You get it? They need to be electrons or ions. Diamond does not has any of them. So
सर
that's
क्लास और कितनी देर चलेगी?
going to be just 5 minutes. Just we are almost done here. We're almost done.
Okay.
Electric conductivity does not conduct electricity. ये बात समझ में आ गई लीन? It does not conduct electricity. जी हादिया, ये बात समझ में आ गई? क्यों नहीं कर रहा इलेक्ट्रिसिटी कंडक्ट?
जी.
इसलिए नहीं कर रहा क्योंकि इसके पास कोई मूविंग पार्टिकल्स ही नहीं है. It does not has any free moving electrons. It does not has any ions. कुछ भी नहीं है. So it does not conduct electricity. Do you get it? Because all of its electrons are involved in bonding. कोई फ्री मूविंग इलेक्ट्रॉन है ही नहीं. कोई ऐसा इलेक्ट्रॉन है ही नहीं जो बाहर निकल के उधर घूमे. ये हम ग्रेफाइट में देखेंगे. ठीक है? Is this clear, everyone? Everybody has got this point?
Yes.
All right. अभी कौन कौन लिख रहा है? जो लिख रहे हैं वो लिख लें. मुझे बताएं क्या करना है.
सर आप एक बार नोट स्टार्ट से दिखाएंगे